Augmentative and alternative communication is a field of study that researches technology that removes communication barriers for people with disabilities. Existing AAC devices include eye gaze systems and switch inputs. Although such technologies have made great advances in providing a voice for those who cannot speak, they can be frustrating for the users to use.
Dedicated AAC systems can be expensive, bulky, and difficult to transport. They also often have a slow input rate, which leads to communication imbalance in conversations.
We met with AAC researchers and reached out to Morse code AAC users in order to identify potential opportunities for our project.
For the past 10 weeks, we have been working on a product that addresses these issues. We sought to create a portable AAC device that someone could use as a lightweight mode of communication. Because users may be limited in the number of switches they can activate, we wanted a language that could be transcribed with just 1 or 2 keys. Morse code fits this criteria because it consists of only dots and dashes. Moreover, it is an established method of communication with existing standards. From here, we began building Morse Decoder. Morse Decoder is a web application that translates Morse code input by a switch device. The web application reads the signals from the switch device using a Bluetooth adapter. Using Morse code, users can input all the necessary characters to form words and sentences.
After background research, we brainstormed potential use cases, crafted interface flowcharts, created development plans, and more.
To get a better idea of how our product would be used in action, we created storyboards to imagine the interactions that would occur. Each storyboard was based off of situations we had heard from real AAC users.
Morse Decoder's algorithm relies on the user's initial calibration speeds. Shown here are the average input times for each type of space during the calibration phase. The user's space information is used to calculate 2 dividing times that separate element, character, and word spaces. When the user inputs new Morse code, the timing is compared against the dividing lines and the input is classified into the proper type of space.
We conducted experiments to see how people who had never used Morse Decoder before would interact with the device. We asked 5 different users to complete 3 tasks. Make an account and complete calibration, tell us about your day using Morse Decoder, and create and use an abbreviation. During these testing sessions, we observed users as they navigated through our product and also got their feedback through a survey given at the end. These sessions showed us what people liked and didn't like, and helped us to pinpoint issues we needed to fix to improve the user experience.
It's important to hear the Morse code.
Morse Decoder was subject to a variety of constraints and limitations which may have hindered the progress we made. This includes difficulties scheduling with needs experts, a lack of funding, and having only 10 weeks to research and build this product. Working on this project made me look at designing technologies from a new perspective. I learned about the vast possibilities of what technology can do for the disabled community, as well as the challenges that arise when implementing them.
Through this project, I learned to deal with the various challenges that came up. The most interesting experience for me was researching existing AAC technologies and contacting potential stakeholders, learning about their perspectives, and designing the project to address their pain